All right, welcome everyone. Thank you for joining us once again this morning for our last day of this AI school. Today's talk is something I'm especially excited about, and I'm very happy to introduce Emily Denton. Emily was like many of the organizers here, a PhD student at NYU, but they are now a senior research scientist at Google. And their work focuses on the societal impacts of AI, which is exactly what today's talk is about. Their current work, which I have been closely following, focuses a lot on the histories of AI and machine learning data sets. So how were they collected? What were the labor practices involved? What are the norms and the values that determined building it, but also its current use? So without further ado, here's Emily with her 2 Zoom joins. I shall mute myself.
Okay, awesome. Hi. So I'm doing something odd where I'm joining audio from one computer and then I'm screen sharing from another. So I'm not sure if you can actually see my face when I'm talking, but hopefully this isn't too confusing. So let me get up my slides. Thank you again for the introduction, and I'm really happy to be here. Okay, so I think you should be able to see my slides okay?
Yes, we can see your slides.
Cool. And I just have one quick question, which is I threw in some pauses for breaks and Q&A. Is that doable with this audience? Does that make sense?
Yeah, for sure. So this is a webinar. People can pop their questions in the chat or in the Q&A, and I can help keep an eye on it and just interrupt you. And if somebody wants to join and speak, we'll just give you permissions to speak. So just raise your hand and I'll allow you to unmute yourself, and you can just ask your question.
Awesome. Cool. Well, with that, let's get started. So I have broken this talk into 3 broad parts. The first one focused on algorithmic fairness and algorithmic harm. The next part focused a little bit more specifically on data sets. And then the final piece, kind of looking more forward, how you and your own research practice can integrate some tools and some kind of fairness tools, ethically informed tools, and so on. And then also a little bit of what the machine learning community can be doing as a whole to try and get us towards some more socially responsible research practices. So with that, I'm just going to dive into part 1. And here I'm going to start off by talking about some examples of algorithmic harm. This is not going to be exhaustive, but I've tried to set it up to serve as giving a kind of sense of different issues that you might want to be attentive to when you're building machine learning technologies. So allocative harm is a term that was developed a couple of years ago to describe harms that stem from the allocation or withholding of certain opportunities or resources. And one of the most classic examples of this is the automated hiring algorithm that might be biased towards one group or another. So I've thrown up a couple of headlines that were in the news a couple of years ago. In this particular instance, Amazon tried to develop an automated hiring tool, kind of surface certain resumes that might be promising. But they received a lot of public critique after this automated tool ended up being very discriminatory towards women who were applying. A more recent and very high stakes example of allocative harm is the use of an automated tool in a healthcare setting. So this algorithm was deployed in the US, and it was designed to help assess patient risk in order to prioritize care. And unfortunately, it ended up perpetuating already existing systemic racial inequality within the healthcare system in the US, and ended up causing Black patients to lose out on really critical care. So I'll get to the kind of why of these 2 examples a little bit later on in the talk, but these are just a couple of examples of the ways in which algorithmic tools and AI and machine learning driven tools can actually end up influencing the ways in which resources or care or opportunities are allocated to different communities in differential ways. So another kind of broad class of harm I've characterized as exclusion from use of a product or service. Joy Polomwini, whose work is depicted on this slide, is an incredible activist and scholar, and she found a couple of years ago that face detection algorithms, just really common publicly available ones, were unable to recognize her darker skin. And this observation kind of kicked off a whole research agenda that Joy and other folks really led into broader examinations of skin tone bias in facial analysis systems. So after Joy uncovered this in her PhD work, she went on to collaborate with Timnit Gebru, and they published in 2018 a really seminal audit that found a broad range of commercial facial analysis systems ended up showing pretty significant disparities in accuracy across different subgroups. And they found that darker skinned women were the worst performing subgroup. So that's the group that had the worst accuracy overall. And exclusion from use of a technology can also lead to allocative harm. So a lot of these harms are going to be kind of coupled and interdependent. So face verification software is rapidly being integrated into a whole bunch of different domains. And so disparities in accuracy in that technology can actually materialize into really tangible harms in different cases. So I've given one example here where there have been a lot of reports of facial recognition-based verification systems. For example, the ones that Uber uses to recognize drivers. There have been examples of these systems sort of failing on individuals with darker skin tones. And in the case of Uber, this can cause drivers to be promptly locked out of their accounts. Other computer vision systems have been audited for disparities in performance. One example here is an audit of a bunch of open source image classification systems. And researchers here found that accuracy of classifying household objects was really contingent on geographical location and the household income of the household that these images are depicted in. So objects that were depicted from Western homes, such as the soap bottle in a UK bathroom on the far right of this slide. Images like this, the objects were recognized with pretty high accuracy. But in contrast, the systems had a much harder time recognizing household items from non-Western homes. So for example, here I've given an example of soap that's depicted in a household in Nepal. And here it was misidentified as food or cooking products. Another kind of broad class of representational harms, another broad class of harms are known as representational harms. And these harms can occur when systems sort of reinforce the subordination of some group along the lines of identity, or also diminish specific groups or erase specific groups. And these kinds of harms can happen kind of regardless of whether or not resources are being withheld. So, for example, the failure to recognize features or attributes relating to particular social groups might be an example of representational harm. I've cited a paper here and they give one particular example. So failure to recognize like culturally significant artifacts like a menorah might be understood as a form of representational harm. And so I already talked a little bit about how individuals with darker skin tones have historically experienced greater error rates with facial analysis technology. And I want to cover a couple more examples that are not classification systems, but still represent an example of a kind of white subject being encoded as default. So the viral face editing app, FaceApp, was kind of in the news a lot in the past couple of years as users started to realize that things like the attractiveness filter would tend to lighten and whiten people's faces. A related example, there's a portrait app that sort of takes a selfie and tries to produce like a portrait version of it. And this app, again, was in the news a bunch because it tended to lighten skin tones and change facial features to produce portraits that were reflective of the predominantly white Renaissance portrait that the model had been trained on. So in the example on the right side of the screen here, this app sort of lightens Tessa Thompson's skin color and turns her braided hair into a hat. There's another paper that was published this year that was examining generative models with faces. And they found a pretty significant lack of diversity with a generic white face being the default. And this is a great paper that kind of discussed this finding in relation to kind of, broader sort of racialized structures in our society and sort of systems that place whiteness as default. So I focus a lot on computer vision systems, but language technologies and other kinds of technologies are also kind of culprits of certain kinds of harm. This is a recent paper that I think is really good. It examines harms relating to gender exclusivity with a particular focus on non-binary identities. Stereotyping is another kind of representational harm that we really need to be watching out for when building systems. Here I've pulled like a really classic example from a couple of years ago where where Google Translate, when it was sort of translating from a sentence where there was no explicit gender markers or gender pronouns, it would end up translating it sort of into a version where there was kind of explicit gender. So here we have the Turkish sentence that basically translates to "they are a doctor," but the system translated this in English to "he is a doctor." And more generally, the system would skew masculine for words like strong or doctor or engineer, and the system would end up kind of producing she, her pronouns for sentences that kind of skewed stereotypically towards feminine words like nurse or beautiful. This particular example was addressed. The actual underlying machine learning system, there's still a bigger problem there. But Google addressed this from like a design perspective several years ago. And so now if you were to type in this sentence, you'll actually see both translations. She is a doctor, he is a doctor. You'll see non-binary pronouns are not represented. I'm pretty sure they're still not represented. So this isn't, kind of a complete design solution, but it does address this, kind of stereotypical male or female associations issues. Stereotype aligned correlations more broadly have been identified in both computer vision and natural language processing data sets. And we've seen these kind of stereotypes filter into word embeddings, which then, kind of manifest in downstream language technologies. And we've also seen activity labeling systems end up kind of being biased in various ways based on stereotypical roles. So another broad category of harms can occur when classification systems label people with offensive, derogatory, or degrading language. There's a project from a couple of years ago that I'll kind of return to a couple of times throughout this talk. But this project was called Imagenet Roulette, and researchers basically tried to call attention to a range of really harmful labels that were embedded in the Imagenet data set. And so these researchers, they developed a classifier that was just trained on Imagenet using the full Imagenet data set. So there's about 20,000 categories. So this is, I'm sure at this point in the course, you're familiar with Imagenet, but there is a smaller version of Imagenet that's typically used for the Imagenet like challenge and benchmarking purposes. And then there's a much larger version of Imagenet that has like to 20,000 categories. And so researchers developed a classifier, trained on the full Imagenet data set, and made it available for anybody to use and really kind of publicized this. And so a lot of reporters and folks on Twitter ended up putting their images in and finding that they were being tagged with racial slurs, derogatory phrases, and other sorts of things. And so this project really ended up sort of making visible in like a really public way the existence of really harmful categories within this data set. The Imagenet creators have since removed a lot of these categories, and I'll, kind of keep returning to this, but, this is something to really be aware of. It's just the existence of, hateful or derogatory terms in a data set that could end up being applied to people. Loss of agency is another kind of broad harm that I think it's really important to be thinking about when developing AI systems. I've given one example here of gender classification systems, and there's a range of gender classification systems that are being developed. I've cited examples here that are focusing on image-based gender classification, but text-based and voice-based and other sorts of data-driven systems are also being developed. And there's a lot of research here that's kind of examining the ways in which the mismatch between, the ways in which people might describe themselves and describe their gender and the ways in which a machine might see and describe somebody's gender can cause kind of very real psychological harm. And there's a broader kind of issue here about denying individuals an opportunity to self-describe, especially when talking about labels relating to identity. Okay, so that's like, broad overview of different kinds of algorithmic harm. Again, not comprehensive, but, trying to touch upon different aspects like allocative harm, representational harm, and so on. So I just really briefly want to dig into this question of who might be most vulnerable to these sorts of harms, because this is really important to think about when building systems and actually trying to assess, is this fair enough? Is this safe enough in a research or kind of product context? So a couple of different things I think are important to think about here. The broad point is this is going to be very context dependent, but it is really important to consider both direct and indirect impact. So this I really think about as a question of proximity to harm. So you might have somebody who is directly interfacing with a product or a tool or something, and maybe they are directly misclassified. What is the experience that person might have? Or you might have somebody who is being allocated resources or an opportunity, or denied resources or an opportunity, and there's going to be some direct impact that they feel. But a lot of these tools have kind of rippling indirect impacts, right? So a system that kind of reinforces a particular social stereotype or reinscribes some kind of normative idea about a particular group, there are going to be broader rippling sort of societal consequences beyond just what is experienced by an individual who is interacting with that system. And so it's really, really important to consider, these kind of direct and indirect impacts. When thinking about who might be impacted, a good place to start is thinking about legally protected groups. So, for example, in a lot of algorithmic fairness work growing out of the US, kind of falls back upon anti-discrimination legislation and discourse. And so this is really focused around legally protected groups along dimensions of race, gender, age, and so on. And so this can be just a good place to start, because we know that these are different axes that, at least within the US, we've seen historically, potential for discrimination with respect to. Again, context-specific assessments are going to be really, really important. Intersectionality is another really key thing to be thinking about, and this refers to the ways in which individuals that kind of live at the intersection of two identity groups. So, for example, we might want to look at race and gender. This refers to the ways in which an individual of a particular intersectional group experiences the world and experiences inequality in a very particular way. So Black women, for example, experience systemic inequality in this country in a very different way than white women. And so if we were to only examine gender or only examine race independently, we wouldn't understand the unique experiences of a particular group and the unique vulnerability of a particular intersectional group. So that's another thing to really bring into considerations. And then finally, this sort of relates to this idea of direct and indirect impact, but it's really important to consider both individuals and communities. So At an individual level, we might want to think about harm that's experienced just by a particular individual. It could still be direct or indirect, but we're just thinking about a specific individual. At the community level, it can be really good to think about how an entire kind of population or group may be defined based on geography or identity group or vulnerable status might experience a particular technology, and the ways in which technologies can potentially increase feelings of inequality or other sorts of things across society. And again, I mentioned that social and cultural context is really, really critical when trying to identify vulnerable groups and assessing potential harm. So I also already mentioned that a lot of algorithmic fairness work is focused in Western contexts, and thus is based on protected categories under US anti-discrimination law. But different social and cultural contexts give rise to vastly different considerations. And I've pointed here to a paper that really tries to, kind of push algorithmic fairness work beyond this very limited Western context. They take India as a particular example and case study and examine the ways in which, in India, caste is a key dimension along which unfairness is likely to arise. And so just porting Western ideas of algorithmic fairness and algorithmic fairness methods to another context is going to give rise to like a pretty big gap. So this is just a really good paper I would point folks to if they want to kind of understand this broader landscape of algorithmic fairness across different social and cultural and geographical contexts. So historical and social context is also really important when thinking about this question of who is most vulnerable. Historically marginalized groups are often going to be those that are most vulnerable. Not always, but this is, kind of good rule of thumb. And this also highlights that not all groups, are kind of interchangeable or equal. And when doing fairness analysis, it's really important to think about the actual experiences that different groups have had in a particular social or cultural context. And the deployment of AI tools is also really going to intersect with existing systemic inequality. So just as an example, it's really challenging to examine fairness of facial analysis tools in the absence of considerations of surveillance technologies more broadly, and the ways in which different groups are vulnerable to surveillance technologies. And then one final thing to be thinking about is that harms can be compounded by an individual or a group's previous experience with related technologies. So, just to come back to some of the examples in this talk, they explored how facial analysis systems, have been observed to fail at higher rates for individuals with darker skin tones, the ways in which whiteness has been encoded essentially as a default into a lot of technologies. And the key thing here is that, these are not isolated instances. And so kind of harms can be compounded when somebody kind of repeatedly experiences, okay, this technology was not built for me. I was not considered when this was being designed. And so really kind of thinking about these, sort of cumulative impacts that it can occur across time is really important. Okay, so part 3 of this first section, I'm gonna go through some potential sources of harm. And I want to emphasize again, this is not exhaustive. And it's very challenging to try and isolate singular sources of harm. So what I'm going to try and do is give an example of things that you might want to be thinking about and attending to when designing your own research projects, when developing AI tools, because these are things that could potentially give rise to sort of real world tangible harms. So to start, data. Data is a really big factor. There's a ton of different biases that can come in at the data level, and I'll go through a couple of them. So I talked already about how image classification systems have been audited and observed to have pretty significant disparities in accuracy with respect to images from different countries. And in particular, we saw a bias towards higher accuracies for images depicting Western households. So this is not that surprising, actually, this finding, once we dig into the data. And folks have looked at a couple of these common data sets like Imagenet and Open Images and found that the images were actually sourced predominantly from Western countries. So the fact that these systems are failing on images from non-Western countries is, again, fairly unsurprising. We can also see imbalances within a particular data set category. So one really kind of good and clear example of this comes from looking at a toxicity classification model. So there is a tool that was developed to classify text and in particular comments that were posted in online forums. And this system was designed to classify text as sort of highly toxic, basically a toxicity score of like low toxicity to high toxicity. And this system was examined by a whole bunch of different people many years ago, I think starting in about 2018. And users found that the system would produce really high toxicity scores for sentences that just had certain identity terms included in the sentence. So for example, the phrase, "the Gay and Lesbian Film Festival starts today," might have been flagged as really toxic. Whereas a similar sentence like "the Toronto Film Festival starts today" would be given a low toxicity score. And the key thing here is that "the Gay and Lesbian Film Festival starts today," not a toxic comment. I can't really think of anybody that would classify that as highly toxic, but the system was cueing in on the existence of these phrases, gay and lesbian. And the folks who are developing this system, they did a really fantastic job of responding to this and kind of digging into the data and trying to understand, okay, why was this happening? And one of the things that they found that was contributing to this pattern in performance was that there was a really high overrepresentation of identity terms relating to minoritized groups in the toxic comments of the data set. So in other words, phrases like gay or lesbian showed up in the toxic comments in the data set at much higher rates than they showed up in the non-toxic comments in the data set. And so this team has since done a lot of work to kind of mitigate these issues, but this is just a really clear example about how skews within particular categories can give rise to, skews in false positive or false negative rates in a model. So this also reflects a broader issue with text data sets that Bender and Gabriel and other colleagues discussed in a recent paper from last year. So a lot of large data sets based on text often pull from various internet sources such as Reddit or Twitter. And these platforms themselves can tend to overrepresent particular hegemonic viewpoints, due in part to the structural barriers that make these sites less welcoming to marginalized communities. And so consequently, misogynistic, white supremacist, ageist, and other kinds of oppressive viewpoints can easily become overrepresented within text corpora unless really careful kind of curatorial mechanisms are included in data set development. And thus these data sets can ultimately end up encoding biases that are potentially damaging to marginalized communities. So for example, to go back to this previous example here, it's very likely that this data set just didn't contain a lot of positive or affirming statements about minoritized groups because it was, being scraped from these internet sources that tended to just be disparaging toward these groups. Okay, so another thing that can happen is human bias and subjective judgments can enter data sets through the annotation process. So I've given like a pretty simple and easy to understand example of this on this screen. I really like to highlight it. The example comes from this paper, Seeing Through the Human Reporting Bias. And the basic idea here is that if you ask people to describe what they see in the top image, people tend to respond with bananas. But if you ask people to describe what they see in the bottom image, they'll say things like green bananas, unripe bananas. And the sort of justification for this difference in answers is that typical bananas, prototypical bananas, the stereotypical banana is yellow. And so the top image just depicts what people typically think of when they think of banana. But the bottom image, there's something atypical. They're green, they're unripe. And so people will tend to actually call out this atypical aspect when they are asked to describe things. And so this kind of immediately begs the question of what kinds of prototypicality judgments might come in other examples that are a little bit more high stakes than just when describing bananas. So more broadly, social stereotypes can affect implicit prototypicality judgments. We might see somebody annotate the top image with doctor, but actually call out gender in the bottom image because there is this social stereotype that doctors tend to be male, at least in the US. So again, the stakes can be quite high when we're talking about images describing people. Multimodal data sets also kind of add in additional concerns here because these data sets tend to have very unconstrained text descriptions. So here I'm giving an example of the COCO captions data set. And a recent exploration here found that words associated with evaluating physical attractiveness, so words like sexy, beautiful, pretty, these words were overrepresented when describing images that were depicting women relative to men. And so this sort of points to a kind of male gaze that gets embedded in this data set, where images that the annotators sort of perceive as being female also get annotated with these adjectives like sexy and beautiful. And this also again kind of begs the question of what other sorts of normative and possibly objectifying views of beauty or other kinds of assessments of social groups might get embedded in data sets where annotations are really kind of unconstrained and free form like this. So I discussed this briefly already, but recent audits of Imagenet and other data sets that were based around the same categorical structure revealed the existence of a range of harmful categories, including racial slurs and derogatory phrases. And so here, the key thing is that, this is not an issue of dataset bias in the sense that some group is being over or underrepresented. This is just an issue with the basic categories that are structuring the data set. Just the inclusion of racial slurs and derogatory phrases as a category is in and of itself problematic. And one of these audits also found a lot of explicit imagery of women, non-consensual explicit imagery of women specifically in these data sets. Another audit of a multimodal data set that was recently developed from image and alt text pairs on the web found that this data set contained slurs, stereotypical depictions of different groups, and explicit content and all sorts of other kind of problematic things. Okay, so another kind of thing that we need to be thinking about on the data side is the ways in which historical patterns of discrimination and inequity can get encoded in data. So in the kind of intro slides, I discussed this automated hiring tool that Amazon developed. And in this particular instance, one of the potential causal mechanisms for discrimination in the automated tool is the way in which the system was designed based on past employment data. So to give a really simple example, if a company that has predominantly hired, let's say, white men, uses its past hiring data as an example of successful candidates on the job, then that's going to filter into any tool that's built off of that data. If the resumes that are surfaced as successful resumes, don't include female names, don't include, female colleges or, historically Black colleges and universities, then resumes that do include those terms are likely to get screened out. So that's just like a really, really simple example that, folks are now kind of fairly aware of this, but at the time that this was being done, this wasn't really considered. I also talked about this healthcare tool that was developed to help identify and manage patients based on risk assessments. So this particular system, the actual kind of causal mechanisms for how and why things broke down are fairly complicated. But one thing that does come into play is that this system equated healthcare needs with healthcare costs. Right, so it's really hard to kind of quantify and estimate the healthcare need of an individual, and so the developers of the system fell back upon a proxy, which was healthcare costs. But the key thing is that in the US, access to healthcare is not evenly distributed across groups, and in particular, it's not evenly distributed across racial groups. More money is actually spent caring for white patients versus Black patients. And so when healthcare costs were used as a proxy for healthcare needs in this system, it meant that Black patients ended up losing out on a lot of critical care. Predictive policing tools are another example where historical patterns of discrimination and more specifically, like, corrupt and racially discriminatory patterns of policing end up filtering into the data sets that are used for these tools. So this kind of brings me to another way of framing this entirely, which is in terms of measurement of target variables in a data set. This ties both into, kind of details of a data set as well as problem framing, and also kind of highlights the, difficulty of isolating a specific source of an issue. But broadly speaking, in most cases, AI systems are being deployed to predict properties that are not directly measurable. These are sort of, properties or constructs that need to be operationalized in some very specific manner. And this process itself can end up encoding various sorts of biases. So just the kind of examples that I went through here, predictive policing tools that equate crime patterns with policing patterns are going to end up, kind of reinforcing discriminatory patterns of policing. The healthcare risk assessment system that I described used healthcare costs as a proxy for illness, right? But again, because care is not evenly distributed, this ended up producing a system that was racially discriminatory. Again, kind of equating a successful job candidate with previous hiring and, retention patterns, again, is going to run into the same sort of issue. Okay, so just focused a lot on data and kind of measurement of variables within data. And I want to talk about a related thing, which is just kind of problem framing and task definitions and assumptions. Again, this is very related to data because particular task formulations tend to get embedded at the data stage. But just a couple of examples of really concerning things that we see here with respect to task definitions is that there is a very long history of trying to infer sort of character traits and like inner characteristics of people from external facial features. So, modern AI is now, so I've given this kind of historical example on the left slide, which is composite portraits of human types from Francis Galton. And this is, kind of debunked pseudoscientific attempts to classify people's character based on physical appearances. And this is sort of, a tradition that was developed to produce and maintain racial hierarchies. On the right-hand side of the slide, we see modern AI kind of reviving these previously debunked pseudoscientific attempts to classify people. The example I've given here is an attempt to predict criminality from facial features, which really is kind of a direct parallel to Francis Galton's composite types. So I think there's two key points here. One is that these historical traditions are being revived, which is sort of problematic in and of itself. But the second and possibly more urgent point is that modern AI and kind of big data are reviving these previous technologies of human classification under a new veneer of sort of mathematical objectivity. And so this kind of elevates the stakes. We have these previous things that were debunked, are incredibly problematic, were designed to produce and maintain racial hierarchies. We thought we'd move past it, but now AI tools are kind of reviving this. And because it's based on data, these tools often end up going, sort of uncritiqued. There's a lot more to read about this. I would recommend this blog post from a couple of years ago that sort of details this troubling resurgence, titled Physiognomy's New Clothes. And then there's another great paper about lessons from the archives, and this focuses a little bit more about the data side of this and the ways in which we can, really try and attend to these issues from the perspective of data set development. And finally, just want to emphasize that this isn't just happening in a research context. Faceception is a pretty concerning startup that claims to be able to reveal a host of qualities about an individual just based on their image. Some of the categories that are available are things like high IQ, white collar criminal, and terrorist. So again, these are real tools that are being developed and impacting real people. So returning to gender classification again, this is just another example where the actual category structure and the underlying assumptions of a task are going to be directly responsible for harm. So the problem framing in these kinds of systems is flawed in that they're designed based on the idea that gender is sort of stable category and that it's knowable from appearance, and sort of neither of these things are true. Also, so again, kind of coming back to Imagenet, which is a running theme here, in response to this work that revealed all sorts of problematic categories of the Imagenet data set, the Imagenet developers ended up removing a whole bunch of categories from their data set. They removed all the racial slurs, the derogatory phrases, and more broadly, they removed what they considered to be non-imageable categories. But this, again, kind of, highlights the ways in which data sets historically have been developed with really unclear requirements and task specification, right? How non-imageable categories were embedded in an image data set to begin with, right? It's a really kind of key question. Okay, so far we've talked about data and problem formulation and assumptions and the ways in which they can all give rise to different kinds of algorithmic harm. But there's also various aspects of modeling that's really important to be attentive to. So traditionally when building machine learning systems, we generally, train and select models in order to maximize some measure of performance or accuracy. And this is often focused on an aggregate accuracy metric. But it can be really important to consider how a model is performing for different subgroups of a data, for example, different gender or racial groups. And I'll get to, in the final section of this talk, I'll kind of, get to some tools and techniques that you can actually use in your own work. But the overall idea here is that it can be really important to try and think beyond just aggregate accuracy. Maybe you want to optimize for a particular fairness metric or kind of trade off between aggregate accuracy and a fairness metric. And so what you're actually optimizing for is going to have a really significant consequence in, the ultimate patterns of performance that your model has, and the extent to which it causes harm. Okay, so it's also important to understand more broadly the ways in which ML systems can be fallible and brittle. This paper here that I've cited doesn't specifically approach this from a fairness perspective, but it does look at the ways in which machine learning systems can pick up on artifacts in a data set to inflate performance gains, and the ways in which this can lead to real world harms when models are deployed without attending to these kinds of gaps in generalization. I would just, kind of dig into this paper. Again, it's not explicitly kind of from a fairness perspective, but understanding the ways in which models can fail to generalize is really, really important for being attentive to these kind of real world harms. Harms can also result from the ways in which systems are deployed in practice, and in particular, the ways in which they're integrated into high-risk domains. So I've given one example here. This is a report from Georgetown Law, and this report is looking at how facial recognition systems are used within a law enforcement context in practice. And these tools are trained on images of people, and they're trained to try and kind of match a face to an existing face in a database. But when they're used in practice, there's actually very little kind of regulation or policy guidance that constrains what can be used as a probe image. So this report found examples of police officers using composite sketches as probe images, and then using those matches to generate leads. Another example that is fairly ridiculous is there was a case where a police officer, put in a photo to the face recognition system. There was no match, but then they looked and they said, hey, this person kind of looks like Woody Harrelson, a celebrity. And then they downloaded a photo of Woody Harrelson from the web, put that into the facial recognition system, and found a match, and then used that to generate a lead. Right, so the authors of this report kind of characterize this as garbage in, garbage out. And the key thing here is that there is often a really big gap between the kind of ideal setting in which tools are developed and how they actually are used in practice. And so we really need to be thinking about who is using these systems, to what end, and in this particular example, how these uses intersect with existing systemic inequality. Okay, so I think maybe I'll pause there for like 3 minutes in the event that there's any questions before moving on to part 2. I like the comment, we need to yell yellow bananas, not only bananas.
I love
There you go, you can talk.
Hi, I just had a question on how do you propose we optimize the right factors to see in algorithms?
Yeah, so I'll get into this in the third part of the talk, which is actually like, okay, here's a bunch of problems. What do we do about all of this? I will say that the answer is going to be context specific. So when we get to that part of the talk, I'm not going to give a one size fits all solution. I am going to give pointers to different tools that can help an individual researcher or developer kind of make a contextualized decision for what's appropriate in a particular context. But I'll get into that in the final section. So far, this is very much like, hey, what are all the problems? But don't worry, I will try and get to, what can we do about this? And what are the tools that you have available to you to help minimize the potential for harm?
Got you. Thank you. I also had a question how does it like relate to your work? So like at Google, like do you like search for these faults usually day to day, or?
Yeah, that's a great question. So I in particular, so I'd say there are teams at Google that focus very specifically on Google products and trying to identify, points of failure, points of breakdown, and kind of, I guess, like I phrase it as proactively trying to identify some of these issues so that they can be, understood and mitigated before something goes live and, people are actually impacted by it. That's not my personal work. I don't do a lot of work closely with Google product. My work is much more focused on actually like academic machine learning research communities. I'm really interested in how machine learning researchers are approaching their work, are developing data sets, are working with data sets. And this comes partly from my background is as a machine learning researcher. So that's kind of my expertise. I'm very familiar with how that community operates. And also I think that research and like academic research is so entangled with product in machine learning in particular. And so trying to understand and intervene in the ways in which research communities are operating, I think actually can do a lot towards shifting how products are developed and how tools are used in practice in real world contexts. So that's where my research tends to focus, but other folks, like other colleagues of mine who work in the responsible AI space, take, I guess you could think of it as a spectrum. Some of us are doing more academic research, others are partnering more closely with product teams, and there's the whole spectrum at Google and within the organization that I'm part of.
Got you. Yeah, thank you. I guess like you're sort of like a bridge between like the academia and like the product side, I guess.
Yeah, definitely. I sort of characterize my role as a little bit more of like an academic style researcher, but a lot of the, I guess, like, here's an example. So some stuff that I'll come to this later in the talk. So some stuff that my team has worked on is the development of like model reporting and documentation frameworks. And those were developed in an academic context. They were published as academic papers. And they were initially explored in the context of like research papers and academic models and reporting in that context. But that also has huge and direct relevance for how Google as a company develops and documents its AI product. And so Google has since taken that framework and applied it to their, I think they applied it to their Cloud Vision API, which is an image classification tool that they've released for general use. So that's an example of something that kind of starts off as academic research, but then actually ends up being integrated into a product context within Google. And there's a lot of examples of things like that. And we also, we try and integrate in research that doesn't just come from our team, but that is just generally being produced in an academic setting, and figure out, okay, what would this look like to, kind of apply these insights in practice in a particular product context. Okay, I think for this, I should maybe keep going. Does that sound good? Cool. All right, so I'm gonna kind of go pretty fast through the data side of things, just so I can get to the recommendations at the end. But the first kind of overarching point that I want to make here is just data set bias is kind of inescapable. So far we've examined various forms of bias that are prevalent in machine learning data sets, and we have examined the ways in which those particular biases give rise to particular kinds of algorithmic harms. But the point I want to make is that there is no kind of magical solution of just, oh, we need an unbiased data set, right? Data sets always embed a particular view of the world. Data sets are kind of laden with subjective values and judgments and imperatives, and it's sort of impossible to strip this from a data set. So just as a really quick example, to kind of come back to Imagenet again, there's a great blog post here that examines how social practices of photography and image sharing on the web give rise to a very particular view of the world embedded in this data set. So within Imagenet, hammerhead sharks are seen as objects of scientific inquiry, trout are viewed as dead trophies, and lobsters are viewed primarily as food. The key thing here is that this is, you might say, okay, lobsters are biased towards representations of food in this data set, and trout are biased towards representations of dead trophy, and so on. But the key thing here is that there is no universal representation of the concept of a lobster. So there's never going to be like an unbiased representation, because there needs to be some kind of reference point. And so the thing I want to emphasize is that it's just really important to account for the particularities of a particular view that is embedded in a data set, rather than striving for something that is totally unbiased. Again, sometimes the phrase unbiased might be used as a synonym for balanced along certain dimensions. And so in that case, it would be great to just kind of quantify, what do you mean when you say unbiased? Data, unfortunately, is rarely actually kind of contextualized in practice. Data sets are often kind of uprooted from context and treated as sort of black box tools that we just utilize in our daily research practice. Historically, data decisions have gone really heavily undocumented, and ground truth labels have often been characterized as fact. Even highly political categories like race and gender have historically been presented as sort of natural categories in a data set, and annotation demographics are often underspecified, based on this presumption that annotators are interchangeable, and annotation discrepancies are often attributed to human error rather than differences in perspective or subjective interpretation. Again, so all of this kind of contributes to data not being appropriately contextualized or kind of described. But again, bias is sort of inescapable. But not all bias is created equal, right? So the statement that like there's no such thing as an unbiased data set is not a call to just do whatever you want with data, right? We know a lot of the examples of data sets that I've discussed so far, such as Imagenet, have tended to privilege a largely white, Western, and male viewpoint. And so it's really important to understand the particularities of a view that's embedded in a data set. Some key questions I think it's like really important to be asking if you are working with a data set or developing a data set are things like, what groups are reflected in the data, what groups are underrepresented, how are different groups represented, are there social stereotypes that are getting reflected in the data through some mechanism, how are people described and labeled, what are the social views that are embedded, and so on and so on. And I'll give in the final section a lot more concrete recommendations for how to situate data in context. But this is just kind of an overview of, bias is inescapable basically, and so we need to account for it. So I want to really, really briefly kind of talk about data subjects, because so far a lot of what I've talked about is harm to people impacted by systems trained from data sets. But data subjects and data creators are another really key stakeholder that it's important to be considering when developing data sets. So many of the most commonly used large-scale data sets, in particular image data sets, have been developed from scraping images from the web through search engines and photo sharing websites. And these data collection efforts historically have been carried out outside of the bounds of any rigorous ethical oversight mechanisms to protect data subjects or data creators. Informed consent is rarely sought, even when biometric information is being collected and distributed, like face data. And to be clear, this is not that data set developers have gone against the law, or done something illegal. This was fairly common practice, these kinds of web scraping practices. But what we're seeing is the kind of landscape of social awareness and landscape of social acceptability is really shifting. And there is growing public awareness and growing concern, as evidenced by a kind of flurry of media articles that have been talking about these practices of social media data scraping. There's also been, like, in response to this growing public awareness, the development of tools that can help give data subjects knowledge of whether or not their social media images have been used in common facial analysis data set. So this is, you know, kind of an effort to give data subjects some kind of control over their data. But field of computer vision and machine learning more broadly currently really lacks centralized structures of data governance. And so even if data subjects kind of find that they are identified in a data set, it can be really hard to actually retract their images from a data set. Data sets are generally hosted on personal websites rather than institutional repositories, with not a lot of mechanisms in place for tracing who is accessing the data and for what purpose. And so again, this gives little control after the initial distribution of a data set. And due to this lack of centralized storage on institutional repository, we often see that data sets kind of, even after a data set is retracted, copies of a data set might still exist on other websites, or papers might still be published on the data set. This is a great paper that's kind of examining all of these different challenges, and in particular challenges to kind of traceability of data subjects. Okay, I'm gonna jump right into the last section and then hopefully save a bunch of questions for the end, because I really want to make sure that I get to all of the like actual tools and things that y'all can use. Okay, so I'm gonna talk about oh wait, sorry, I missed an entire part. I put that question slide in the wrong spot. Let me talk a little bit about benchmarking practices before going into the tools. Data sets provide our primary means of benchmarking and evaluation in the field. And so it's really important to also examine data sets from that evaluation perspective. There we go. Data sets also play a really important role, not just in kind of comparing and contrasting specific algorithms, but also actually centralizing, you know, or organizing research agendas and coordinating researchers around shared problems. And so it's, again, just really important to examine data sets from this perspective, because they shape research agendas in like really value-laden ways often. So very high level kind of overview here, but there are some really great benefits of benchmarking being this dominant mode of evaluation, right? As I mentioned, they can coordinate researchers around shared problems and goals. They allow for standardized methods of comparison, and they can also relax a deep need for domain expertise in a problem space. But there's a bunch of risks that I think folks, you know, in the field should be attentive to, which is state-of-the-art chasing practices can lead to overfitting on certain data sets and can lead to a distortion of scientific progress. Can also stunt the development of new ideas by disincentivizing approaches that are not optimized for overhyped benchmarks. It can also disincentivize work connecting models more carefully to domains. So all of this is to say that you know, when you are doing research, when you are evaluating your methods on standard benchmarks, just be really attentive to, you know, what benchmarks you're choosing, if it is the most appropriate way of evaluating a model, you know, the kind of gap between benchmark evaluation and things that we actually might care about more broadly in terms of measuring progress within the field. One other thing to attend to here from a kind of, you know, social inequality perspective is that machine learning research is very heavily concentrated on data sets from a small number of Western and elite institutions. And so given the influence that benchmark data sets have on the trajectory of the field as a whole, this is sort of cause for concern from a social and ethical perspective. Okay, so now I want to get into like things you can do. I'm going to review a whole bunch of tools and techniques that you can integrate into your own work, and also discuss some bigger shifts that we're seeing within the machine learning community, and also where, I think we need to do a little bit more. This is going to be like a big information dump, but like lots of links out to things. So I hope there's some like useful stuff here that you can bring into your own work. So first off, fairness metrics. So this is kind of getting back to a question that was asked in the previous break. There are a whole bunch of different definitions of algorithmic fairness, and each of them kind of carries with them a different kind of social understanding and might be relevant for a different situation. As an example of some of these, there is a class of fairness metrics known as group-based fairness metrics, where the idea is to take an error statistic, such as false positive rates, and look at that error statistic across different groups. So for example, compare false positive rates across different gender groups. And a system would be deemed fair under a particular formulation of group-based fairness if that error statistic is equalized or sufficiently equalized across those different groups. There's a ton of different other kinds of definitions. And so I pointed here to two fairly accessible resources. The first is a tutorial that was run in 2019 that explores 21 different definitions of fairness and the kind of politics that come along with them. And the other is a book, it's a full book that's available online, focused on fairness in machine learning research. And I think these are two really good jumping off points. If you are building a system and you're asking, what fairness metric do I choose? What should I optimize for? Again, there's not going to be a one-size-fits-all solution. And so these resources are going to really help you kind of make the kind of contextualized trade-offs. More generally, ethics-informed testing is really important to bring in. So comprehensive disaggregated evaluations are really key. As I mentioned, traditional ML paradigms tend to focus on optimizing a particular model statistic, such as accuracy, but aggregate evaluations can miss how a particular model performs on different data types and different individuals. So it can be really important to compute metrics over subgroups. How you define groups will be context specific, but different subgroups that are relevant for your application. And then also considering multiple metrics. Because they can each provide different kinds of information. And then intersectional groups are key. So this comes back to what I was mentioning earlier about intersectionality, but it can be important to look at unitary groups. So for example, how men or women are performing, or how lighter or darker skin tones are performing, but then also looking at the intersection of these. So darker skinned women, darker skinned male, lighter skinned women, lighter skinned men. So to give you a couple of more specific things, because again, it's like everything is context dependent, what you do with that. Here are some really, really good resources that have been put together. So this is an example of different toolkits that have been developed to help with kind of fairness related testing and optimization. These are all, I believe, designed for Python. Now some more specific tools. The what if tool is a really useful tool. It facilitates interactive and visual debugging of black box models. Basically, you can use this tool, plug in your model, and you can test performance in hypothetical situations. That's the kind of like what if situation. And you can also analyze the importance of different data features, and you can visualize model behavior across multiple models and subsets of input data. And you can also evaluate your model for different machine learning fairness metrics. So this is a really, really versatile tool that's fairly easy to just kind of plug and play with your models. A follow-up to this tool is the language interpretability tool. It's also an open source tool, and it's more specifically designed for visualization and understanding of natural language processing models, so text. And with this tool, users can, explore model internals, explore prediction explanations, look at fairness metrics, do counterfactual generation of their text. So counterfactual being like, he did this, she did this, swapping out pronouns, swapping out names, swapping out other sorts of things that might relate to different social groups. Okay, so I looked at models. Now what can we do with data? Because we talked about data is really central to some of these issues. So broadly speaking, it's really important to understand your data, right? This can be helpful in order to identify spurious cues or data set artifacts that can be gamed by a model. Examining your data can help identify labeling errors, edge cases, and it can also be really important to examining potential socio-demographic cues within your data. Some tools, Facets is an open source data set exploration tool, and this enables users to explore the distribution of different values across features in their data set. So just a really nice, easy visualization tool. A related, but a little bit more powerful tool is Know Your Data. And again, this is an open source tool, but it offers like machine learning driven signals. And so it can, because it is powered by machine learning, it can provide a little bit more signal than just what is there in your raw data set. And so this can be really, really useful for, kind of examining data set bias, looking at correlations across different signals and trying to understand some potential issues that might arise if you were to use this data set to train a machine learning system. There's a lot of fairness interventions that actually happen at the data level. So earlier I described this toxicity classification model that was over-indexing on terms relating to certain identity groups. So I gave the example of non-toxic sentences that just contained the terms gay or lesbian being flagged as toxic, even though the sentence itself was totally fine. It was just talking about a film festival, but included the term gay and lesbian. One of the attempts that the team developing that tool took to try and mitigate that issue was actually just to get more diverse data, right? As I mentioned, one of the issues there was that terms relating to LGBTQ groups were just predominantly in the toxic comment. They didn't have a lot of affirming comments that were referencing those terms. And so the data-oriented intervention that they took was to just go out and collect affirming comments from LGBTQ communities and get people to just give them more data that had, terms like lesbian, transgender, queer, gay, and so on appear in the positive comments. Another example of this is the diversity in faces data set. This was a data-oriented intervention that came in response to all of the work I discussed that showed facial analysis systems were performing really poorly for darker skinned subjects. And so IBM researchers went out and developed a very, very large data set of 1 million images that was designed to be balanced across different sociodemographic lines. So balanced across binary gender groups, balanced across different skin tones, and so on. But it's important to remember, kind of coming back to the conversation about data subjects, that practices of data diversification, in particular when drawing from public data sources, are not without flaws. So the diversity in faces data set actually received a lot of public criticism because it scraped social media photos without consent. There's another example of a data set that was developed by scraping YouTube videos that transgender creators had uploaded documenting their transition. And again, this was used to train facial analysis systems. So, this points to a limitation of data diversification as a fairness intervention, because we need to both be considering, the models that are developed from these systems, but also the data subject and the ways in which data gathering operations, can kind of produce new harms and reinscribe other forms of domination. And moreover, data isn't always the most appropriate intervention, right? We've talked about how harms can stem from problem formulations or problem assumptions. They can stem from the use of particular categorical structures. And we also need to understand how technologies fit into existing social systems. For example, the ways in which facial analysis systems fit into existing surveillance and policing regimes. So diverse data can be an appropriate intervention in some cases, but it's not a kind of be-all and end-all solution. So another kind of data-oriented intervention that has come about is actually just the full removal of entire data sets or the removal of specific images in a data set. So I mentioned this already on the bottom of this slide. The Imagenet authors, in response to these audits that were finding the use of really problematic categories, they actually just removed entire categories from the data set. Tiny images, which use the same categorical structure as Imagenet, the authors there just fully retracted the data set. They were like, there's no way for us to fix this. We're just going to fully retract it. So that's another example of a response that's come about from some of these concerns. Another sort of data-oriented intervention is to just minimize the use of images depicting people entirely. So this paper describes a recently proposed image data set that does not depict any people, but can still be really useful for model pre-training. So they kind of characterize it as an alternative to Imagenet, but just with no people. And they show that it has similar sort of utility that Imagenet had. Okay, sorry, I seem to have thrown this questions and break slide in odd places. I did this morning when I was like, oh no, I should give people breaks. And clearly I was not caffeinated. Okay, transparency, I want to talk about a little bit. So a ton of different considerations come into play when thinking about transparency, right? We need to be thinking about different stakeholders and the different needs and the different kinds of communication that they would benefit from. So examples of some stakeholders might be practitioners using a data set or model, data subjects, regulators, policymakers, direct users of a product, and so on. And so these are just different individuals to be thinking about if you are trying to, document something that you're doing, communicate something that you're doing. Just think about the different audiences. Some frameworks that you can use in your own work. So model cards is a model transparency framework. And this is basically a framework that allows model developers to organize and communicate key information about a model in a really standardized way. It can also help model creators sort of reflect on and think through like assumptions that they've made, potential harms of their system, implications of use, and so on. And for model consumers, it can provide like really important information to facilitate decision-making and kind of build trust sort of downstream. So this is actually what I was talking about in the past like Q&A session, this was an academic paper, but now it has been productionized. And Google has actually developed the Model Cards Toolkit, which is an open source library that facilitates and streamlines the creation of model cards. And I've linked to this here. And the website also gives examples of model cards that Google has developed. So you can kind of see what does this look like in practice. So this is a fantastic tool, I think, to just bring into your own research practice. You know, if you're publishing a model, consider publishing a model card with it. And this is becoming more and more commonplace. Comprehensive model reporting, this is kind of related, but I think it's also just important to think about metrics beyond sort of top line accuracy metrics. So energy consumption, model size, fairness metrics, error analysis, and so on, and kind of incorporate this into your papers and potentially your model card if you're developing. Okay, now on the side of data transparency, data sheets is a standardized framework for transparent data set documentation. So a lot of kind of parallels to the model transparency in terms of the benefits for dataset creators and dataset consumers. There's also many more proposed frameworks. I've linked to a bunch here, and there's kind of more being developed, probably as we speak. Each of these frameworks approaches documentation from a slightly different lens, but the broad sweeping objectives here are to provide standardized frameworks for transparent documentation. A couple ones that I want to pull out and highlight. Data cards offers a structured way to facilitate sort of data documentation and so on. And the data cards playbook that I've linked to here is a really, really useful people-centric resource to help create customizable data set documentation. And there's a ton of fantastic resources at this link, including guidelines for thinking about what different stakeholders might be, what level of communication is important for different stakeholders, and so on. So this is just a fantastic resource that can help you navigate all of the nuances of data set documentation. Another really good framework is this framework that is sort of thinking about transparency, but in the service of accountability. And this paper here offers a documentation framework for every single stage of the data set development lifecycle. And so the idea is that you could bring this in and, kind of document things at every single stage. Okay, in closing, I just want to talk about a couple broader things. So these were all like tools that like you could use in your own practice, but obviously a lot of the stuff that I've talked about goes beyond just an individual researcher. So this is some encouraging things. We're seeing a shift in the valuation of data work within the field. NeurIPS released this year had an entirely new track focused on data sets and benchmarks. Historically, data work has been really undervalued, but this new track is a really good example of a shift in that valuation. And so I've linked to a blog post that kind of outlines the motivation for this, and then also an incredible set of accepted papers that I'd really encourage folks to dig into. We're also seeing the recognition of data as central to machine learning research. There's a great workshop that was at NeurIPS. A lot of this is focused on NeurIPS because it like just happened in December. Ethics reviews and checklists. We're seeing a lot of conferences try and think about how to integrate different kinds of ethical oversight frameworks into their reviewing processes. So this is a blog post outlining what NeurIPS did this year. I know a lot of NLP conferences have their own ethical review processes. I don't know of any computer vision conferences that have integrated this in, but hopefully that's something that will come. But there's still a long way to go in developing more rigorous ethical oversight mechanisms within the field, because we really kind of don't have any sort of standardized things here. And so really want to be thinking kind of as a community how to develop mechanisms of legal and professional accountability that protect data subjects, that protect downstream users and other folks who are impacted by the products of this research community. I kind of skipped through this. These are just some good readings. Basic point is everything that we're doing is highly value laden and political. And so, we really need to be accounting for that in our research. And again, I think this is just sort of how we are conceptualizing our work as a field, but it's really important to be shifting focus from intent to impact. Finally, research is contingent and situated. Our own social positions influence what we know about the world, what we kind of understand about the research that we're doing, and kind of bounds our understanding of potential harm. And so really important to be thinking, what are the limits of your own experience and knowledge, and the limits of experience and knowledge of those you might be collaborating with, and what can you do to try and attend to those gaps? Really thinking about these broader questions of who has a say in the development of AI, right? Who's most likely to experience positive benefit? Who's most likely to be harmed? These are the kind of broader questions that I think it's really important for us all to be considering. And with that, here's some recommended reading. There's links throughout this whole slide deck, but if you want some easy intro books, if you're going to take one book away from this talk, I would say Race After Technology is a phenomenal introduction to a lot of these issues. Automating inequality focuses a little bit more on like allocative harm that I was talking about. Data feminism and design justice are really, really great examples of how to bring kind of feminist techniques and social justice perspectives into our work. And artificial whiteness is just a really good overall kind of book that's examining kind of whiteness as default that gets embedded into a lot of these tools. So I'll stop there. I'm at time. Thanks.
Thank you so much. We do have a couple of questions if folks can stick around for another like 5 minutes or so, which means our office hours will start a little late, but it's okay. The first question that is related to a slightly earlier section of your talk is, you mentioned that bias is inherently present in data due to more data being sourced from Western countries. Is that inherently because more people in the West have more access to these technologies, or just a choice in the data that is being used?
Okay, so just to rephrase the question, it's about where these kind of Western biases are stemming from.
Yeah, like, is it because only Westerners use technologies, or it's a choice in what data to use?
Yeah, I mean, I would say it is. So I would definitely push back against it being an issue of only Western folks using these technologies. Rather, I think it's an issue of predominantly Western individuals developing these technologies, right? So this is, a lot of AI technologies are deployed around the world, right? And they're, we're kind of building for a global, in theory, building for like a global population. But the reality is that, a lot of Silicon Valley is concentrated, a lot of tech is concentrated in Silicon Valley. I was going to say Silicon Valley is concentrated in Silicon Valley, but that is redundant. Right, so we have, predominantly Western, institutions, researchers, engineers, and so on, who are developing tools that end up getting used way outside that context. There are, some examples where, there might be skews in data sources, right? So like I gave an example of a bunch of data sets that were, images were sourced predominantly from Western countries. I don't know exactly the mechanism by which that bias was introduced, because I believe, so one thing you could think of is, okay, if you type in, English terms, you're probably going to get images that are coming from English-speaking countries. But I do know that in the development of those data sets, terms were actually translated into a whole bunch of different languages, although how many, what was the coverage around the world, right? Those are things that I'm not sure. But those kinds of things can impact kind of where data ultimately gets sourced from. And then there's another level of this, which is, okay, if a data set is being developed and it's predominantly Western individuals that are developing that data set, they might just not be thinking about context that they're not familiar with. Again, I think this is shifting. People are a lot more aware now about what it means to build for a broader global context. But, when these data sets were being developed, 5-10 years ago, I think that was just not top of mind. And the people for whom it might have been top of mind for were just not in the room. So I think that's one answer, is just like, where people are situated really influences the kinds of issues that they think of when things are being developed. I'd say a bigger and more complicated issue is that even now, where I think there is broader recognition that we need to be building for a much more global context, there still is this gap in knowledge and understanding, right? Building responsibly for a particular population requires a lot of contextualized knowledge about that population. And so even if we're like, okay, we want to do this thing, if we don't have that knowledge and expertise, that's going to create a huge barrier to actually doing that responsibly. And so again, this is just another dimension of the issue of who is in the room when these tools are being developed, right? So it's not just like, kind of having the knowledge that there is a problem, but also having the expertise and the kind of the situated knowledge to actually attend to it in practice. So I'd say those are the different kind of dimensions there that really come to mind.
Thank you. The next question by Satsalam is, Given how easily machine learning models can adopt bigoted viewpoints on accident, is there some history of online trolls or shock sites that have used machine learning to deliberately generate offensive content that you're aware of? Yes.
Oh, that's interesting. Not explicitly that I know of, but I would say like a lot of large language models have been open source and are kind of available for people to use in that manner. And so I mean, this is a bigger question, I think, around what does, I think sometimes we can err on the side of like, oh, we want to open source all of our models. We want to make them as accessible and available as possible. We want to democratize AI and so on. But when, for example, a really large, powerful language model has the propensity to generate all sorts of abusive and toxic comment, what are the consequences of open sourcing that model? How can you really kind of do that in a safe way? There's so much to say there that's kind of, beyond the scope of this talk. But that is like a very active conversation that is, happening within the community, basically, is, I guess I would characterize this sort of as dual use, right? Like you can have a system that could be really, really valuable for some purpose, but it could be kind of co-opted and used for something else. And so what does the responsible open sourcing of that technology look like? Are there ways of licensing it, putting it in terms of use, controlling it in some way? In many cases, like probably not. So anyways, I would say my short answer is I don't know specific like websites that do this, but I think there is generally a, you're identifying like a real kind of cause for concern here.
And there has been plenty of recorded use of like deepfakes, which is also very concerning.
Exactly.
Given our limited time, I'm going to wrap up 2 questions into a single question by Sadman and Hector. Are there current metrics in place that check the biases of researchers and developers? And do you think the diversity of a team working on developing these systems and the lack of diversity thereof could contribute to biases in machine learning and AI systems?
Yeah, so yeah, I would say that is one of the like overarching themes of, this kind of whole thing is who, like the question of who is actually involved in developing a product, developing a data set, building an academic model, kind of shaping the agendas of the field. Like the question of who those people are, what social identities they hold, what their kind of social and cultural backgrounds are, is critical to kind of thinking about how biases are produced and who is ultimately being harmed. So yes, there's a great, I actually didn't cite this, I usually have a section of this talk that's actually focusing like a little bit more specifically on this, but there's a great report from AI Now that I'll drop in the chat. It's called Discriminating Systems, Gender, Race, and Power in AI. And it just very clearly kind of sets up this line of argumentation. Basically, the like people that are responsible for developing things in the field, like that is deeply coupled with the actual harms that are being produced by this technology. And in particular, you think about kind of gender inequalities and racial inequalities within the field and the ways in which that relates to racial discrimination and gender discrimination in the tools that are being produced. So I'd say that's my answer to part of the question is a resounding yes, these are related. The question of like metrics in place that check the biases of the developer or researcher, that's a little bit more interesting and nuanced, I think. Because, I think really what the question is how are there frameworks to facilitate an understanding of gaps in knowledge, gaps in understanding, really kind of reflecting on positionality of researchers and developers, and the kind of consequences of that. And I'm gonna drop in another resource here, which is the best thing I can think of here. I'd say it's less of like a checklist type thing, but it's a tutorial that was run at FACT a couple of years ago called Positionality Aware Machine Learning. That's like the article relating to it. Oh, here we go. This is a website that I think is really useful. And so positionality, I reference this in my talk, but just for clarity, It refers to the ways in which, our individual kind of identities and lived experiences shape and bound our understanding of the world, and can contribute to kind of gaps in knowledge and understanding. And it's, positionality, it's sort of inescapable, right? It's kind of the ways in which I was saying, like, data set bias is inescapable. You can't remove positionality, you can't remove the ways in which it influences work, but you can be attentive to it and try and account for it. And so this website that I just linked gives some like resources basically and frameworks that researchers can use to be attentive to their positionality and understand how that might factor into the development of models, the choice of metrics, data annotation, and so on. So I think that's the best resource that comes to mind when thinking about this question of like, okay, how do we like check for the biases of researchers and developers?
Thank you so much. All right, I'm sure there are more questions, but unfortunately we are over time. And it's time for folks to break for lunch. Thank you again, Emily, for joining us. This was an excellent talk, and I hope everyone here learned a lot. Awesome. Thank you, Philip.
The slides I shared and my email address is on there. So if anybody wants, if there's like more questions, feel free to reach out and I'll do my best. And yeah, thanks for the invite. Have a great day.
Yeah, thank you so much. Briefly announcing for everyone here, all the students, we have a break for lunch and also office hours. So if you have any questions, pop in. And then starting at 1, we have a few lightning talks, which will be the end of this week. So thank you all for coming. Goodbye.
I would add that the lightning talks are the best way to cap off your labs because they will involve people talking about directly how you go from doing the labs to actively doing research in those areas. So I would strongly recommend attending them because they're 20-25 minutes each, so that shouldn't take much time either. Sweet.
Goodbye, folks. See you shortly at the lightning talks. Bye.